This is John. John seems to attract all kinds of bad weather and natural disasters wherever he goes. See for yourself. One day, John notices his dog is restless. The pooch keeps scratching the entrance door and wandering around the house. He even tries to hide in the corner, howling and barking. When some mugs start to clink in your cupboard, John realizes what it means. The noise is produced by foreshocks, mini earthquakes leading up to the main event. Earthquakes often happen in clusters. After a few weak quakes, a much bigger one is likely to be on the way. Sometime before the disaster strikes, people might notice bizarre blue lights. Some of them seem to be coming out of the ground. Others are hovering in the air. These are earthquake lights. They may appear days or mere seconds before the ground starts shaking. Now, John is walking along the ocean shore. Suddenly, he sees the water retreat from the beach. Really fast. Uh-oh. John, run away as quickly as you can and find some high ground. A tsunami is coming. And your life might depend on how fast you react. If John spots a bizarre and unexpected rise in sea level, it can be another sign of an approaching tsunami. This happens in 40% of cases. The incoming water is the first tsunami wave. The second one, way larger, will come in about 10 minutes. John can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. John feels there's something strange about the sun. Through his special super dark sunglasses, he sees that there's some uneven flares around the star's contour. If these bizarre rays are accompanied by auroras all over the world, they're a sign of a solar storm. Such storms are usually caused by disturbances in the sun's magnetic field. In this case, the bursts of gas and radiation on the surface of the sun get so massive and powerful that they can even reach our planet. Luckily, solar storms aren't really dangerous for people, but they can mess with electricity and even cause blackouts. The sky over John's head is darkening and turning ominously green. Something hits him on the forehead. Ouch! He picks up the offending object. It's a hailstone, but it's not that cold outside, and it's not raining. Soon, he hears some noise. It's approaching rapidly and turns into a loud roar. It sounds as if a freight train is moving towards him, but it's not a train. It's a tornado. The funnel isn't visible behind a cloud of debris, but John can't mistake this rotating column of air for anything else. Are you on the road, John? Then get as far away from your car as you can. Fast! Find a ditch, lie down in it, and cover your head. Oh, you're inside? Then get away from the windows and hide underground if possible. And please, John, be very careful if you spot some conically shaped clouds. Those mean severe storms. And if you notice that such a cloud starts spinning around, immediately search for shelter. The cloud is transitioning into a tornado right in front of your eyes. On the bright side, John should only worry about warm conical clouds. Cold ones are totally harmless. The only problem is to figure out the temperature of the cloud he sees. Duh! Ah, look. John just spotted some weirdly shaped trees. They look like the letter J and grow on a slope. It means the ground under John's feet is likely to be unstable. If he keeps wandering around, it can cause a bad landslide. Square waves appear when two different wave patterns crash into each other. This phenomenon does look kinda awesome. No, don't go into the water, John. Keep watching it from the shore. Cross currents in that spot can easily pull even a skilled swimmer under the surface. John keeps walking along the shore. At one point, he sees wild, choppy waves carrying ocean debris and seaweed. This time, he stays out of the water. He knows it can be a sign of a strong rip current. It can carry a swimmer far away into the ocean. How about a walk in the park? John likes this idea. The sun is shining and the sky is so blue and beautiful. Suddenly, he spots a rapidly growing vertical cloud. At first, it looks bright white. But as it approaches, alarmingly fast, it becomes dense and inky. The sky is darkening. It's getting windy. That's when the guy notices that his hair stands on end. It's his cue that he's about to get hit by lightning. At this very moment, positive charges are rising through his body. They're reaching towards the negatively charged part of the storm. If he doesn't react fast, these charges will meet. There's nowhere to hide, so John should crouch down and try to make himself smaller than the objects around him. Oh no. John, don't lie down on the ground. It may be damp and thus a great conductor of electricity. There are other signs that scream danger during a lightning storm. John's palms may begin to sweat. He might hear bizarre crackling and buzzing sounds coming from metal objects nearby. His skin can start tingling. There might be a strange metallic taste in his mouth. Plus, John is likely to smell chlorine. That's how ozone smells. Electrical charges split the molecules of nitrogen and oxygen, which are the main gases making up the atmosphere, into separate atoms. When these atoms come together again, some of them produce molecules made up of 3 oxygen atoms. That's ozone. We can smell it during a thunderstorm because downdrafts bring this gas from high altitudes to your level. Some bugs can feel a storm coming. They get ready for a natural disaster by freezing. So, when John notices that insects around him look drowsy, he knows to get ready. Oh, and bees can predict heavy rainstorms. These critters begin to work much harder the day before it starts raining. While walking next to the river during a period of heavy rains, John hears a roaring sound. He feels paralyzed with fear. It's likely to be a flash flood moving in his direction. Indeed, he soon sees debris coming down with the flow. The water is rapidly changing its color, becoming muddier and darker. Flash floods are very, very dangerous. Take care of your safety immediately, John. Another day, John sees a spectacular wall cloud. It seems to be stretching for up to 5 miles. In the best case scenario, it's just a severe storm coming. But if the wall cloud begins to move in a circle, it's a sure sign of a tornado. John is walking across a snowfield in the mountains, listening to the sounds the ice under his feet makes. The noise is kinda hollow. Quickly check whether there are cracks around your footprints, John. If so, the chances are an avalanche is about to happen. Soon, John sees an avalanche moving in his direction. He does his best to get off the slope. In most cases, he could probably outrun it by heading downhill and then veering sideways, but not this time. He realizes he doesn't have enough time and heads for the nearest tree. If John keeps holding on to it really tightly, the avalanche might not pull him along. But if this doesn't work, he should try to swim up to the snow's surface while the avalanche is still moving. On a pretty nice summer evening, John notices leaves with soft stems droop all of a sudden. It might be because of an upcoming storm. Right before extreme weather arrives, the air usually becomes more humid. Leaves also get damp and heavy, and the wind easily flips them over. John lives in a pretty old house and is used to having cracks in the interior walls, but one day, he notices that some of them have widened. And look, there are a few new ones. It's an alarm bell. He lives in an area with loads of limestone, so new cracks can mean a sinkhole is about to open next to his house. John is hurrying home, trying not to waste time admiring shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft, and these ominous clouds most often mean a storm is coming.
I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme, 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you. Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet, and your bulky spacesuit, you'd run a bit more slowly there. at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature: awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds, and against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour.
In 1996, one of the most vigorous snowstorms in history hit the east coast of the U.S. It was named Blizzard of 1996. From January 6 till January 8, a huge amount of snow fell in the country. The storm was so strong that people couldn't see anything around except a white veil. Huge snowdrifts formed. People couldn't leave their homes because snow had covered all the doors and windows. Someone spent hours shoveling snow to get into the car. And while they were doing this, new snowdrifts appeared around. This is considered one of the main winter storms of the 20th century. Schools and universities didn't work. Shops, libraries, and cafes were closed. You could look out of the window and see nothing but a white ice wall. The wind lifted snow into the air and blocked the movement of cars. People abandoned their cars to hide in the nearest shelter, which created many miles of traffic jams. During the snowfall, hurricanes formed and destroyed buildings. Chaos reigned everywhere. People were afraid to leave their homes. Strong wind and rain forced rivers to come out of their mouths, which caused massive flooding in nearby cities. Many states lost millions of dollars because of the destruction. However, at that moment, the residents of one small town didn't notice the problem. The blizzard of 1996 covered almost all of Pennsylvania, but the weather was not so bad in Delaware County, aka Delco. Neighboring cities were attacked by the storm, but not this one. Since about that time, a legend has appeared among the locals. They say their small town is protected by a mysterious weather bubble. In 2013, they called it the Delco bubble. According to the locals, the bubble covers the entire Delaware County and protects it from all natural disasters and other hazards. Residents of a quiet, sunny town like to talk about this phenomenon, but there's no scientific evidence of its existence. It seems bad weather bypasses the district during huge storms. As soon as the hurricanes approach this place, they break up in different directions and then converge right after passing this area. All this happened according to the locals' words, without meteorological evidence. They remember several different storms in the 90s, including the blizzard of 1996. They announced that the storms would reach Delaware on TV and radio, but in fact, no forecast came true, and the residents enjoyed pleasant weather. One resident says that he often looks at forecasts and satellite photos and sees how black clouds disperse in Delco. It's peaceful and comfortable here. It seems as if time has stopped here too. However, the bubble doesn't protect against all problems. There were some floods there, after all. So, many residents don't believe in anomalous protection. There's one scientific explanation proving that storms are weakening in this place. Sea breezes go inland and settle in places like Delaware County sometimes. The streets and surroundings are filled with cold air. This creates air stabilization. Then when a storm forms and goes here from the west, it meets this stabilized air mass. Hurricanes lose a significant part of their strength, so it seems as if bad weather simply bypasses the district. Also, the Delco bubble can be explained with the help of psychology. Almost all rumors about the protective anomaly come from people. Residents write on social networks and tell each other about how the hurricane didn't touch their homes. In such cases, people often think that if trouble didn't happen to them, then it didn't happen at all. Imagine you go out on the porch of the house while the radio predicts a strong storm. Everything is calm before your eyes. A light breeze blows in your face. But behind, a few hundred feet away from your backyard, a real hurricane is raging. You didn't see it and went to write a post on the internet that the Delco bubble saved your city again. Storms are a dangerous weather phenomenon, and you should be wary of them, especially if you don't live inside a protective bubble. But let's say you missed all the news and reports about an approaching thunderstorm. It's okay. You'll know it's approaching you thanks to the clouds. One of these clouds is called cumulonimbus. These are precursors of thunderstorms, hurricanes, hail, floods, and even tornadoes. You will easily recognize them by their formidable appearance. They are thick, heavy, dark, and can sparkle because of the lightning created inside. The first reaction to such clouds is to escape or seek shelter. But wait a minute. Let's see how they form. The warm air lifts the smallest drops of water. They are so tiny that they form steam. Most often, this steam rises from the ocean. Since there are several times fewer of them on land, they rise high into the sky in an area with a very low temperature. There, the warm steam cools down, and the droplets turn into tiny particles of ice. Then, these frozen pieces are mixed with other particles that the planet is filled with: dust, ice, and sea salt. All these things stick together into a homogeneous mass and create a cloud. Millions of other extra particles stick to it, and the cloud becomes more voluminous. The mass increases and drops begin to fall to the ground in the form of rain. Clouds are necessary for the planet. They protect us from the strong radiation of the sun's rays. You could say they filter the sun for us. When night falls, the clouds act as a blanket. They keep warm and don't allow the cold to penetrate inside. Almost all clouds are formless. The human imagination comes up with what they look like. But there are rare clouds that have a clear, striking shape. Lenticular clouds. They are stationary and have the shape of a huge round plate. These clouds often cover mountain peaks. Mammatus cloud. They often form under cumulus rain clouds. They look like hundreds of huge bags filled with water hanging over the ground. If the sky looks like gasoline is spreading all over it, you see nacreous clouds, common for areas with rather low temperatures. You can see it in places closer to the Arctic Circle. They get this color thanks to the sun. It shines on the clouds at a certain angle and creates this pattern. Morning glory clouds are like huge ropes stretching along the ground. You can observe this phenomenon in northern Australia. So let's go down from the clouds to the ground and look at the mysterious phenomenon hiding among the swamps. For centuries, people have been observing this strange thing. Some called it fool's fire. At night, somewhere far from civilization, you can see mysterious bright lights among forests and swamps. They glow with orange and blue colors. It seems like somebody has lit a torch and now is waving it to attract your attention. Perhaps someone needs your help, and they are signaling about it. In the past, people thought so too. They walked towards the lights and found themselves in the swamps. Now, they needed help, but there was no one around, and the mysterious lights just disappeared. Walking through swamps is very dangerous, so don't let these lights catch you in this trap. You should know that there's a scientific explanation for this phenomenon. Bioluminescent fungi and algae grow in swampy places and sometimes glow with a blue color. From afar, this creates the illusion of a small light. Wind and water sway algae with mushrooms, so it seems as if lights are flying. Also, there's a lot of organic material in the swamps: leaves, grass, mud, clay, tree branches. This stuff decomposes rapidly in wet conditions and releases methane. As soon as the methane comes into contact with the air, it ignites and flies over the swamp in the form of a burning ball. This phenomenon is observed all over the world in swampy areas, but the most famous flying lights are in the West Texas desert. They are called Marfa lights. Each of them is the size of a basketball and always appears in the desert. The lights flicker, merge, divide into two parts, fly away into the sky. However, there's no scientific explanation for this phenomenon. Maybe these are just lights from passing by cars. However, many people think that Marfa lights appear for the same reason as spook lights over swamps. There are large reserves of oil and natural gas with methane hidden under the desert. Sometimes, this gas comes out of the ground and gets fired after contact with oxygen.